in question 4 of our self-test for our 5.3 section, which is about factoring and graphing polynomial functions. Okay. So we left off on 4e. Now, 4e had a misprint in it. It was not meant to have this constant term at the end here. It really should have just said e of x is equal to x cubed minus 2x squared minus 24x. And I apologize to you if you spent as much time as I did trying to solve it. That was my bad. All right, so to graph this, we really have to start by factoring it, and we should start with the easiest kind of factoring. I can see some common factoring, so I'm going to factor that x out to the front. And we get x squared minus 2x minus 24. And then that's a just simple trinomial, right? I can find two numbers that add to 2 and multiply to negative 24. And I believe they are 4 and negative, oops, that should be a negative 2 and negative 6. 4 and negative 6. So that all becomes x plus 4, and x minus 6. Okay, so we're going to sketch this guy out. So first thing we'll do is start with our x-intercepts. That's our A step, right? So our x-intercepts are going to be 0, x is negative 4, and x is 6. So I'll get a point of 0, 1, 2, 3, 4, x at negative 4, and 1, 2, 3, 4, 5. Make 5 a little bigger, 6, and 6. So there are our 3 zeros, also our y-intercept. Great. So we know this is a cubic function, so this is cubic. So therefore, there's 2 terms. So the leading coefficient is positive 1 here, so it's positive 1. So therefore, when we graph it, it's going to end up going upward because it's positive. So it's going to finish going up to positive infinity. And my y-intercept is already graphed. E of 0 is 0. And there is no multiplicity. So that means when we graph this thing, it looks like it's going to look something like this. All right. And that's our graph. Simple as that. All right. So we'll move on to 4f. So I can see in 4f that I can factor an x out of all of those terms right away. So that's the first thing I see. So I'm going to start with a common factoring step. So I'm going to start by bringing out, I like to bring out a negative if I can, so I'm going to bring out a negative x. And I get x cubed plus x squared, take away x, take away 1. All right. Then I've got this 4-term thing. So that's common factoring, of course, right? That's common. Now I'm going to see if, I can factor by grouping there. So I'm going to try that. F of x is equal to negative x. And I can factor an x squared out of that term to get x plus 1. And I can factor a negative 1 out of these guys and get x plus 1. So I can actually rewrite this as negative x times x plus 1 times x squared minus 1. That, of course, is factoring by grouping. And, of course, now we have this other thing that has to be factored, and that's a difference of squares, right? So we can go one step further and say it's negative x, x plus 1, x plus 1, x minus 1. So I'm going to just stop at this point and just see if I've crashed the system, because I crashed it a couple times already today, and it's very frustrating. So my mouse works. Is this counting? The clock's still counting upward. It's been on 4 for a long time. Alright, I'm going to try pausing it, see what happens. Unfreeze. Okay. Looks like it's still working. Alright, so sorry about that. Okay, so I see some multiplicity here. So we're going to get some multiplicity. Two roots that are the same. Do multiplicity. Can't spell today. Alright, so we're ready to graph. So let's start with our x-intercepts. So we get our x-intercepts at x equals 0 from this x term. X is -1. We get that twice. And we get x is 1. Alright, so we can sketch those out. And we get a point at 0, -1, and +1. Okay, so what else do I know? I know that this is a 4th degree polynomial. So therefore there will be 3 terms. And I know that a leading coefficient is -1. So when we're all said and done, it's going to head downward because it's negative. And so that means we're going to have an arrow going down from our last root. Okay, we already found our y-intercept because we had an x-intercept of 0. So f of 0 is 0. And there is a kiss multiplicity of 2 at x equals -1. So that'll make a kiss. Alright, so I'm not sure if the kiss is going to go up like that, or if it's going to go down like that. So we're not necessarily so sure, but we don't have to be. So when we connect these dots, maybe I'll connect them from the back here. So I know it's going to pass through here, and it's going to turn to come down here. And it's got to hit 1, but it's got to have a multiplicity of 2. It's got to kiss, so it's got to come down like that. And that's our function, f of x. So there we go. Okay. So we're going to move on to G. For G has 5 terms. It's a quartic function, which is bad news because it means we have to do more work, unless we can be crafty or lucky. So the first instinct I have is to check for other kinds of factoring before I start, but it doesn't look like I can see any common factors. I don't have any way of grouping with 5 terms. Probably going to have to just turn to polynomial factoring. However, this arrow implies that actually I did find the factors earlier in question D. I found all the possible rational roots because it's the same function here. So I already know my possible roots. So we found them to be the factors of 24 because the leading coefficient here is 1. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, and plus or minus 12, and plus or minus 24. Alright, so we got to try different roots here. I'm going to try 1 to start because it's the simplest thing to plug in. And I'm going to get 1 to the power of 4, which is 1, plus 8 times 1 to the power of 3, which is 8, plus 17, take away 2, take away 24. And that's feeling kind of like it's going to even out to 0. So let's just check here. So those positive terms, 9 and 17, it gives me positive 26. And these guys give me negative 26. So we get 0 when we're done. Therefore, we can conclude that x minus 1 is a factor of g of x. Okay, so that means that we can use this to determine or simplify this expression by dividing it out. X power 4 plus 8x cubed plus 17x squared minus 2x minus 24. And I'm just going to run through this pretty quickly. X cubed minus 8x, oops, pardon me, x cubed, x power 4, jeepers, what a mess. So I get 9x cubed plus 17x squared, so I'm going to add 9x squared, 9x cubed minus 9x squared. I'll subtract them, and I get 26x squared. Take away 2x, so it's plus 26x. 26x squared. Take away 26x. So we subtract, and we get 24x. Take away 24. Plus 24. 24x. Take away 24, and we're done. Okay. So the purpose of that, of course, was to find this quotient here, because that quotient now finds our way into our g of x expression. We take our factor x minus 1, and this guy becomes the second part of this expression, 9x squared plus 26x plus 24. Okay, so we have to continue factoring. I'm going to stop and check if I can factor this by grouping. It doesn't look like there's similarities between the coefficients here, any patterns or any symmetry. So I'm going to have to continue factoring. I'm going to call this q of x just to make it separate than g of x. I call it q because it was a quotient. And I'm going to continue using my possible rational roots because this expression can have all the same possible rational roots as this one because it ends in a 24. The leading coefficient is 1. So in theory, 1 could actually still be a factor of q. So I could test 1. However, I can see all these guys are positive, and so I'm going to need a negative number in there if they're going to come together to give me 0. So I'm only going to try negative numbers. So q of negative 1 gives me negative 1 plus 9, take away 26 plus 24, which sounds like I'm not necessarily super far from 0, but I'm just going to test it because I feel a little tired right now, so I'm just going to use a calculator to test. Negative 1 plus 9, take away 26 plus 24, and up is 6. So it's not equal to 0. So I can conclude, therefore, x plus 1 is not a factor of q of x. Okay. So I'll move on, and then I'll try negative 2 next. Again, I need a negative somewhere in this expression to get down to 0. So no point trying positive numbers. So a negative 2 cubed is negative 8 plus 9 times 4, that's 36, minus 2 26s, that's half of a deck of cards, so 2 of it is a full deck of cards, 52, plus 24. All right, and again, looking like it might even out to give me 0. So I'm going to try negative 8 plus 36. Take away 52 plus 24. And we get 0. Nice. So therefore, x plus 2 is a factor of q of x. All right, so just like we found this x minus 1 was a factor of our function, so we went to long division. We're going to take this and say, okay, we're going to do another long division here, x plus 2. And hopefully this will require fewer steps because there are fewer terms. We get x cubed plus 9x squared plus 26x plus 24. All right, I'm going to run through this pretty quick. X squared, x cubed plus 2x squared. Take away 7x squared plus 26x plus 7x, 7x squared plus 14x, 12x plus 24 plus 12, 12x plus 24. Take away, we get 0. Okay. So again, this guy is now going over here. So we've got g of x is really equal to our x minus 1 times our new factor, x plus 2, times our last thing to be factored, x squared plus 7x plus 12, which is a quadratic function. And I know how to factor that. It's not a function, sorry, it's a quadratic expression, but I can factor it, so I know these two numbers plus add to 7 and multiply to 12. And when I look for those numbers, those are 3 and 4. So we can say actually g of x is equal to x minus 1 times x plus 2 times x plus 3 times x plus 4. So when we want to sketch this thing, so we'll start with our x-intercepts. Our x-intercepts are at x equals 1, -2, -3, -4. Those are our roots. So we've got a root at 1, -2, -3, -4. Okay. So b, we'll find the degree. So it's a 4th degree. So we should have 3 turns. It is leading coefficient is 1. So therefore, it ends going up to positive infinity. So I'm going to draw that in right here. And the y-intercept is -24. G of 0 is -24, so it's going to be, we'll call it down here, -24. And and I don't have any multiplicity. No multiplicity. So when I sketch this thing, I'll start from this end. It's got to come down. Maybe it passes and keeps going, loops back up, comes down, goes up, and there's our nice pretty g of x. And of course that's at 1, -2, -3, and -4. Okay, there's our graph. Okay, last one. So for h, so we get this function here, h of x is equal to -x to the power 5 minus x to the power 4 plus 5x cubed plus 2x squared. And I can see I can start by common factoring. So I'm going to start by doing that. So I'm going to take out a -x squared. Get x cubed minus, plus x squared minus 5x minus 2. And it doesn't look like I can do any factoring by grouping there. So I'll just check here and say, okay, we'll call that whatever, q of x. And the possible roots of that guy looks like it's just plus or minus 1 or plus or minus 2. So it's not a lot to try. So I'm going to try 1. I don't think 1's going to work. Not 2 either, because there's no way, or sorry, not -1 either, because that 5 is just so powerful. I can't overcome it just by putting 1s in here. I can't do any competition. So I'm actually going to start just at 2. So let's say q of 2 is 8 plus 4, take away 10, take away 2. And it's 12, take away 12 is 0. Therefore, x minus 2 is a factor of q of x. Okay. So we're going to take that guy and we're going to say, okay, well, x minus 2, we're going to divide that into x cubed plus x squared minus 5x minus 2. And we'll say, okay, that's going to give us x squared. X cubed minus 2x squared. And it's going to give us 3x squared minus 5x plus 3x. 3x squared minus 6x. And that's going to give us x, take away 2, 1. Interesting. Minus x minus 2, that gives us 0. Okay. So we take that value, we say, okay, well, we're going to get a new function. So we've got h of x is equal to negative x squared times x minus 2 times this thing, x squared plus 3x plus 1. Okay, so that is a trinomial, but it doesn't look like it can be factored because there's no two numbers that add to 3 but multiply to 1. So we got to use a quadratic formula for that one. Okay, so our roots, our x-intercepts, so we get 0, x is 0, but we're going to have that twice. X equals 2, and x equals negative 3 plus or minus the square root of 9 minus 4 times 1 times 1 all over 2. Alright, so that gives us x is equal to negative 3 plus or minus the square root of 9 take away 4, which is 5, over 2. This looks sort of familiar. So x is negative 3 plus root 5 over 2, and negative 3 minus root 5 over 2. Okay. So I'm just going to see what we got there. Negative 3 plus root 5 divided by 2. So x is approximately equal to negative 0.4, and negative 3 take away root 5 divided by 2 is x is also approximately equal to negative 2.6. Alright, so I'm going to take those values and sketch them. So I've got a value at 0. I'm going to space out my distance for 1, 2, 3, just because I want to give myself some space to write these guys in. So negative 0.4, that's right here. So I'm going to call that my negative 3 plus root 5 over 2. And I've got negative 2.6. So that's negative 3 minus root 5 all over 2. Okay. So those are my x-intercepts. All right, so B, I'm going to find my degrees as a 5th degree polynomial. So therefore, we're going to get 4 terms. So we have a leading coefficient of negative 1. Therefore, it's going to look something like this. We're done. So we're going to get a downward arrow down like this. The y-intercept, well, h of 0 is going to give us 0. We already sketched it. That's our y-intercept. And there is multiplicity of 2 at x equals 0. So there will be a kiss. And we're not sure if that kiss is going to go up like that or it's going to go down like that. Okay. So now's the time to connect the dots. So we know this guy's going to come through here, right? And it's going to come down. It looks like it's going to kiss here, dip right down again, and pass through there. 1, 2, 3, 4 turns. There's our function h of x. Okay.